Hey, good morning, happy Tuesday, good afternoon, and good evening, whenever you decide to open this. It is Tuesday. A couple things this week. Number one, there is no chemistry live this week. I'm sorry about that. I just don't have a lab that fits into what we're talking about this week. So there is no chemistry live today at 10 a.m. There is no chemistry live Thursday at 1. There's no chemistry live this week. We're taking 1 week off. We'll go back at it full speed next week. But there is no chemistry live this week. Okay, so today what I want to do is I want to expand a little bit more on the acids and bases. So if you remember the last time we talked, whatever that means, we gave you 3 definitions of acids and bases. One of them, and it was Lowry and who's Lowry's buddy? Ha! I can't remember our other gentleman's name. Lowry and starts with a D. What's his name? Bronsted. There it is. Lowry and Bronsted. They defined, right? There's different definitions, but their definition was one of them donated an H plus, and one of them accepted an H plus. So I want to use that one today, that definition today, and look how acids and bases donate and how they accept. Excuse me. So I do want to show you this one slide. So remember, Bronsted and Lowry said acids donate. They're rich in H's. Bases accept. Okay, they're the acceptor. They're poor in H pluses. And so the way I always remember is B base, B borrow. The borrower is the base. So when you're looking at an equation and trying to figure out, well, who's the giver, who's the donator, and who's the acceptor, who's the borrower, remember, bases borrow, B and B. He's also the one going to be poor in H pluses. You're not going to look and say, oh, look at all those H's. Look at all the hydrogen on there. Acids, on the other hand, are going to be rich in H's. And tomorrow we're going to talk about how we name these acids and bases. And one of the things you'll notice about acids is almost always, there's a few exceptions, but almost always acids, when you write out the chemical formula, start with an H. Okay, they start with an H. So let's take a look. If you go on Google Classroom and you go to today, which is Tuesday the 12th, you click on it, it has a worksheet on there, okay? Your job today is to fill out that worksheet and submit it. That's it. Now today together, I'm going to do the whole thing with you. We're going to just work through it. And as we do that, if you are stuck, if you need help, you can watch this. If you're going through it and you're like, I get this, this is easy, push pause, stop the video and just do it. Just do it and you're done. But if you need help, watch the video, fill out the sheet. Watch the video, fill out the sheet. You do that, the sheet's done. We did it together and you're good to go. But when you're done, make sure you click submit. Okay? So without further ado, I want to shut up and get rolling. All right, so here we go. Oh, that's the wrong one. Here we go. So this is what the worksheet says. At the top, the instructions say, in each equation, identify the acid, the base, the conjugate acid, and the conjugate base. What? So what I want to do first, I want to look at my equation here. Okay, and I want to say, all right, well, what do I got? I have HCl, I have NH3, I have NH4 plus, NCl minus. So now remember, just the general rule of an equation is the left side, remember, are the reactants. That's what goes in to the reaction. And then there's a chemical reaction. What comes out when you're done is the stuff on the right. We call that the products. Okay? So the stuff on the left is what goes in. The stuff on the right is what comes out. It's been a while since we talked about just general chemical reactions. I'm going to tell you the acid and the base are always on the left. Okay, so in an acid-base reaction, there were 6 types of reactions we talked about trimester 2 is a long time ago. One of those reactions was an acid-base reaction. So all of these reactions are an acid-base reaction. I'm telling you, on the left side, one of these is an acid and one of these is a base. So you got to say, all right, which one's the acid, which one's the base? I think the easiest way to do that is say, okay, this is what I had going into the equation. When they mixed, when they joined, when they reacted, what came out? Okay? And so you got to look and say what went in and what went out, what went in and what went out. What comes out is a change in H plus. One of these two reactants on the left is going to donate an H plus. One of them is going to borrow an H plus. And remember, B borrow, B base. So I look at HCl and H3. Then on the right, I have those same two chemicals. I have HCl and I have NH3, but they've been changed. They've borrowed or they've donated an H plus. So if I look at HCl, okay, on the right side, I have NH4 and Cl. So let's just look at this one first, HCl. NH4 plus, Cl minus. Well, this first one, NH4 plus, is nothing like HCl. But the one on the right is just like HCl, but it's lost an H and it's lost a plus. Well, I can see, Mr. G, that it's lost an H. That makes sense. But how do you know it lost a plus? Well, look at the charge on HCl. There's no charge, right? But now look at over here at Cl minus. There's a negative charge on there. So remember the rule. If you lose a negative, you become positive, right? I always try to encourage you, man, be positive. Get rid of the negatives in your life. When you lose a positive, though, you become negative. So it's lost a positive. It's also lost an H. So HCl must have been the donor because it donated, it lost it. That makes it, the donors, remember, are the acids. So my acid is HCl. So I'm going to write that down here. Okay. My base is going to be the borrower. So if I look here, NH3 is exactly the same as NH4, except for NH4 has gained an H. That's why it's H4, not H3, and it's gained a plus. So the base is the borrower. So that tells me, all right, my borrower is my NH3. So I'm going to copy and paste that there. There's my base. Half done with that equation. Now the next two say, okay, conjugate acid and conjugate base. What? What the crap does that mean? Remember the definition of acid and base. Acids are rich in H pluses. Bases are poor in H pluses. So this guy had an H plus, but he donated it. He gave it away. That makes him poor. So he's no longer an acid. Once he loses that H plus and becomes this Cl, becomes this Cl minus, he becomes poor and now he becomes a base. So that Cl minus is now the conjugate, is now the conjugate base. The NH4 plus gained an H plus. So it was poor over here, it was a base, but now after it gains, it actually becomes rich and becomes an acid. And so the conjugate acid is NH4 plus. I don't know if I can draw on this thing or not. I don't think I can. All right. And so we just finished number one. Let's look at number two. Same deal. I have my equation right here. The stuff on the left is my reactants. Those are my acids and bases. The stuff on the right are my products. Those are going to become my conjugate acids or my conjugate bases. They are going to become poor or they're going to become rich. Well, let's start with the left. Okay. OH minus, HCN. All right, well, which one's which? Well, OH minus, that doesn't really match up very well with the stuff on the right at first glance. But HCN, well, that one's really, look, that's easy. HCN clearly became CN minus. Well, how does it become a CN minus? Well, what happens? It went from having an H to not. And this one also is a minus. So it must have lost its plus. So if this one's going to give an H plus away in this chemical reaction, it must be the donator. That makes it the acid. So copy and paste. Well, look at OH minus. Well, if I am not the donator, I must be the borrower. I must be the base. Base borrow, BB. If I add an H to OH, doesn't that give me two H's in one O? Or H2O? So this guy's going to be the borrower. He must be the base. So I'm going to put that guy there. Now look on the right. Once they've borrowed, once they've donated, they're going to change. OH will become H2O. Now remember, OH was the borrower, the base. Once it borrows an H plus, it's rich, so it becomes an acid. CN minus gave away, right? HCN, cyanic acid, that's called hydrocyanic acid, okay? That one gave away an H plus to become that one. So its conjugate, what it became, is now poor. Okay, this is poor. So it's now the conjugate base. So the base becomes an acid, and the acid becomes, oh, bummer, becomes a base. I'm going to lose my let me plug in. Real world, right? Okay. Hey, let's keep going. So right away, number 3, PO4 3 minus HNO3. Now, I'm a chemistry nerd. I will acknowledge that. I look at that and say, okay, one of these is the base, one of these the acid, which one is which? I'll be honest, I don't even need to look at the right side because I know that acids almost always start with H's. They almost always start with an H. This is PO4 3 minus, no H's at all. It can't donate, it doesn't have any H's. It can't, it's got to borrow. So if it borrows, it's a base. I know right now, PO4, that sucker's a base. Oops. PO4, that sucker's a base. That means that HNO3 must be the donator, must be the acid. Now what happens? When this donates, doesn't it become that? If I lose an H plus, don't I become that? And this little minus really should be, oops, up there at the top, okay? It becomes this. So the acid becomes the base. Now it's poor in H pluses, right? So that's your base, and the base becomes rich. So it becomes the conjugate acid. So all I want you to see is when acids and bases combine, the acid donates an H plus, the base borrows B and B, and that changes what we have. The rich guy becomes poor, the acid becomes base, and the poor guy becomes rich. The base becomes an acid. And so when I say rich and poor, I'm not talking about money, right? What am I talking about? I'm talking about H plus ions. One more and then two more. Now, this one's a little tougher because I have an H and I have an H. I can't just say one's an acid, what's a base. I actually have to look what happened, right? Okay, here, That clearly became this one. That one clearly became this one. Okay, well, look at it. They lost an H plus. This must have donated an H plus. So HCl, which is hydrochloric acid, must be my donator. It must be my acid. Shoot. This then must be the acceptor because there's always an acid and there's always a base. That's the acceptor. Well, now what becomes what, right? The acid becomes the base. This is going to be my conjugate base. He's now poor. And the base now becomes an acid. He gained an H plus. He's now rich. All right, one more. Has an H, has an H. Well, this one starts with an H. It's probably going to be my donator. Yep, look at it. It goes from it had H, it doesn't have H. So this is going to be my donator. This is my rich guy. He's my acid. Here's my borrower, right? It goes from one H to two H's. So my borrower is the base. And I'm hoping you're starting to get this. All right. The base becomes an acid, and the acid becomes what we call the conjugate base. Okay, that's it. Now, one last thing on the sheet. It's the same thing, but it just says, okay, fill in the table. So on the right, here's your equation, right? And I told you on this one, here's your acid, here's your base. What's the conjugate acid? What's the conjugate base? Well, remember, acids are rich, bases are poor. Acids donate H pluses, bases borrow H pluses. So if I lost an H plus off this acid, okay, and I can see what happens over here in the equation, doesn't this guy become this guy? So that acid is going to become a base. So this would be my conjugate base. This base, H2O water, if it gains an H plus, it becomes rich in H plus, and if it's rich, it becomes the conjugate acid. Okay? Now, next line, I gave you the acid, the base, the conjugate acid, the conjugate base. Where do they go in the equation? Well, hopefully you've realized the acid and base are always on the left side of the arrow. So all I have to do, all right, here we go. Copy, paste. There's my acid. Add to that my base. Copy, paste. And on the right side, I always get my conjugate acid and my conjugate base. So I'm going to paste that on the right side. Oh, what happened? I zoomed up. And I'm going to add to that my conjugate base. So I'm just making the equation out of what I have. All right, now the third one is just like what we did up above. Here's the equation. What's my donator? What's my borrower? Let's start with borrow. B borrow, B base, right? So I look here, NH3 plus HCN. Now I come over here, NH4 plus CN minus. Okay, I can see that this guy lost an H and this guy borrowed that H plus. Okay, so this must be my borrower. NH3 must be my borrow. B borrow, B base. So that's going to go here. This guy donated, right? My donator is going to be my acid. And now I got to say, all right, well, what became what? Remember, the acid becomes a conjugate base, and the base becomes a conjugate acid. All right, last line, and we're done, guys. Okay, here we go. This one's a little tougher. I gave you no equation. I gave you no acids and no bases. Holy cow, so what do? Well, I know With an equation, I always have an arrow. Okay. Now I also know, that the acids and bases go on the left side and the conjugate acids and bases go on the right side. Okay, so I'm going to come and I'm going to say, all right, well, I know these two are on the right. This guy and this guy are on the right. So those are my products. So I'm just going to go, here we go, copy and paste that there. And copy and paste that there. Okay, well, now what goes over here? Oh, this is tough. Well, I got to look at what I have, right? Here I have the conjugate acid. What does that mean? Remember, the acid came from a base, came from a borrower. So if H2O used to be down, used to be less than H plus. So how would I write an H2O minus in H plus? Well, isn't that 1H in 1O? Okay. Now it also lost a plus. Well, if you lose a plus, you must have been a minus. Okay. Now this is really what you got. You got HO minus. Now just heads up. Oh, there it goes. That's going to be up there, right? Heads up. It's never put HO. That's what we have, but the way we write it is OH minus. Okay. I kind of like this guy there. See that? Same thing. So that, okay, this became this. So H2O used to be OH minus. Now again, if this is my conjugate acid, that comes from the borrower. It became rich. It started out as poor. The borrower is the base. Oops. Okay. Now I look over here. All right. Well, this clearly borrowed an H and a plus to become this. Well, where did it borrow it from? It must have borrowed it from the only other. It must have borrowed it from this guy. Okay. So we had C. Oh, man. Struggle street here. Sorry. We had ClO. Okay, let me just format it here. Oh, what did I just do? And that'll be up top. So that goes there. Sorry, guys. That shouldn't be up there. Isn't it fun, technology? Don't you love it? I don't know how to do that. Here we go. We'll do it like this. Okay. So now, this is the conjugate base, but this is after it lost an H. So I must have an H there, and it lost a plus. So this wouldn't be a minus if it lost a plus. It would just be a neutral with no charge. So what do I end up with? I end up with HClO3. So now let's look and make sure that makes sense. That must be my donator. Whoa, what happened there? So HClO3 borrowed an H plus and became Cl minus. And OH minus, sorry, donated. OH minus borrowed an H plus and became H2O. This must be my acid, starts with an H. This must be my base. Okay? Now that's a lot. I get it. If you need help, email me. Let's do a Google Meet, right? I have time open at 10 o'clock because there's no chemistry live, so I'd love to help you, okay? You can text me or Google Voice me, all right? But let's make sure this makes sense. But you have everything you need now. Again, maybe this is really hard for you on the computer. You could tell it was for me. Write it on paper and then just take a picture. That's awesome too, okay? Guys, that's all I have. We'll keep going with acids and base tomorrow, but I want to talk about this conjugate acid, conjugate base. All that means is the rich becomes poor, the acid becomes a base, and the poor becomes rich. The base becomes an acid. Acid becomes a conjugate base, base becomes conjugate acid. Guys, have a great Tuesday. We'll talk to you later. Bye.